Alright, so I started out with a pretty crazy example. That took a long time, right? You're tired and confused, maybe. So I'm hoping this logical equivalence and this step-by-step here will kind of help you wrap your head around the process and make some connections. But we will find out. You just have to let me know how you're doing on this. Like I said, it's going to take some time and practice to wrap your head around this process, and just stay patient with it, and you'll be okay. So what we're doing is trying to show P if and only if Q is logically equivalent to P and Q, or not P and not Q. And so if you notice here, this is listed in the table with logical equivalences involving biconditional statements, okay? But you can't say, see table 8, this proves logical equivalence. That's silly. That doesn't make sense. It's like saying, well, that's the way it is, right? It is the way that it is. That doesn't make sense. So we're going to prove it with all the other logical equivalences that we know. And just like the last example, our working goal is try to get all ands and nots and see what that gets us. And always keep in mind where you're trying to go. Remember? And also, where we're trying to end up has all ands and ors and negations, so that's not that odd of a goal here to try to get all ands and ors. And what I'm noticing with the implication is it'd be nice to write it, or the biconditional, right? It'd be nice to write it as two implications, and then I can write the implication as ands and ors and kind of get on a path there. So so I know for sure I'm going to use this first logical equivalence from this table, and then from there I'm going to think about P implies Q being negation of P or Q, and apply that here, and just see where that gets us. Hopefully somewhere, right? So let's get started. How do you know which side to start on? That's tricky. You could start on either side, okay? It'd be interesting if anybody wants to write up starting on the right-hand side and show this logical equivalence. You can get 5 bonus points for the week. I think that's fair to go in that quiz and quiz section of your grades. But I'm going to start with the left-hand side and prove the logical equivalence. So I'm going to start with P if and only if Q. And you know what? I don't even know why I want to start there so bad, but it just seems like a good place to start to me. So I'm going to start with the P if and only if Q. And I don't know, probably, like I said before, if you've taken trig, you've dealt with proving trig identities, so you might, kind of get a feel of remembering that experience. And so one thing I thought in trig was that we'd always start with the more complicated side, but I don't know if that's necessarily true. It's just kind of start somewhere and see what happens. If you're not getting anywhere, then try the other side. Okay, I don't think there's a hard rule for that. But remember, you can only work on one side at a time. Okay, otherwise you're assuming the equivalence, and we don't know the equivalence yet, so we can only work on one side at a time. Okay, so we're only going to work with P if and only if Q. So like I mentioned from that those logical equivalents involving biconditionals, I know that a biconditional is just two conditionals going in each way. So P implies Q and Q implies P. So I'm going to start here with this logical equivalence, and I'm going to rewrite my biconditional in its equivalent conditional form. Notice I'm only substituting with things that are actually logically equivalent, otherwise it doesn't make sense. And I've got a justification for every single step, and it's very clear, and it will be very clear in your work why you're doing each step. So really work on this idea. I think it'll help us both be more effective. I'll be more effective in grading, and you'll be more effective in this process. So now, again, I want to try to get all ands and ors. Okay, so what I'm going to do next is just use that logical equivalence with the conditional. I know that the hypothesis implies a conclusion is logically equivalent to the negation of the hypothesis or the conclusion. So what I'm going to do is go ahead and replace both of these implications with their equivalent negation or form. And there might be words for this or whatever, but I usually just say, negation or whatever you want to say, but when you're justifying, just write out that equivalence that you're using. Don't worry about the words and names for now. Just write out the logical equivalence that you're applying at each step. Okay? So P implies Q is logically equivalent to negation of P or Q. Again, I think of hypothesis implies conclusion. Negation of hypothesis or conclusion. Hypothesis is Q, conclusion is P. Negation of hypothesis would be negation of Q or P. Okay? Don't get caught up in these P's and Q's, okay? They're going to trip you up. So just think, you know, first, second, hypothesis, conclusion, right? And remember, with the implication, the order is important, okay? So it's really important that you negate just the hypothesis, right? And you don't switch those around. All right, so now we got something to work with, but what are we going to do with it, right? Okay, let's think about where we're trying to go here. I know I want to put the P with the Q, right? And now they're kind of separated, right? These two ors are grouped and kind of separated, and I'd like to have the P but not P. That might help me, but I would also like the not Q to be by the not P. So somehow I need to combine these guys, okay? And the way I'm going to do that is try to think about this first one as just one thing. Kind of think about it like M. Let me put this to the side. Kind of think of it just like some proposition M. If we've got M and not Q or P, we could use distribution here and write, you know, bring that M not with you, M or the middle, M and with you, put or in the middle. So M and not Q, or M and P. Okay, so think on that and see if you see what I'm trying to say here. I think what I'll do, guys, is put in a little quiz here for the correct distribution of. I gotta write this down. The correct distribution of not P and Q, or not P or Q. Over not Q or P. Okay, so pause to do that quiz. All right, hopefully you did that and it made sense. And so now let's think about this. I'm going to use distribution. P and Q or R is logically equivalent to P and Q or P and R. Okay, so I took that P and put it on the Q, separated it by an or, took that P and put it on the R. Okay, notice you can distribute from the right or the left. It doesn't matter as long as you do it correctly. Okay, so I'm going to take not P or Q, apply it to not Q, and apply it to P. Put an or between. Okay. So let's write that out, see what happens. So now this is tricky, right? Because I don't just have P, I have a compound proposition going on. So just be really careful. Make sure you group things appropriately and don't lose any parentheses, okay? And not Q. All right, that's grouped. That's grouped. Or, and we're going to distribute the not P or Q and P. Okay, now this is looking like something we can work with a little bit better, because now I notice, oh, I've got this negation of Q a little bit closer to the negation of P, so that's nice. And I've got the P closer to the Q, so we are moving in a direction that's good. Okay, now notice how we've got a bunch of different operations going on. Well, we have a bunch of and ors. And that's tricky to work with because we can't really move things around in a way that we want to necessarily. So if we could get all ors or all ands or something, that would be wonderful. Probably not going to happen, right? Well, definitely not going to happen, because look at our final product. We should have ands and ors going on. But, and maybe that's not the best argument for the step. Maybe the best argument for the step is just what I said before, that I want to get not Q by not P. And I want to get P by not P. Or P by Q, right, for here. So I'm just going to use distribution again. What I'm going to do is, let's see, the form that I've got going on is an or, which is actually the same as the one I wrote, but it's just a different order, but it still works in the same way. P or Q and R is logically equivalent to P and R or Q and R. And you know, even though the symbols change, the operation and their order and the way that they're grouped stays the same, so that the principle still applies. Okay, hopefully that makes sense. Okay, because be careful here. This statement here is totally different from this, right? The P and the Q do not overlap. Okay, it's just two different ways of stating the distribution process property. Like if that distribution of 5 example, 2 plus 4 times 5, I can use the same principle with 5 times 2 plus 4, right? In that case, you know, our meaning is the same, but this here a little bit different. Yeah. Well, because I've changed the order of my variables, but that's still what we're using here. So what I'm going to do is distribute the not Q to the Q and to the not P, and I'll put an or in the middle. So I'll have, again, I'm going to make sure to group this so I don't get things combined with other things. You know, if you're trying to err on the side, try to err on the side of putting too many parentheses in, okay? So as long as they kind of make sense there, just be careful. Yeah, be careful. Not P. Okay, I'm distributing the not Q to both of those. Now, putting an or between Q and not Q. All right, so what did I do? I took the not Q, the and not Q, wrote it after the not P, so not P and not Q, split it up with an or, and then applied that and not Q to Q. So hopefully that makes sense there. And I'm just going to focus on that little piece for now. I could do that with the second one, but let's not bite off more than this one step. Okay, one step at a time. Right? Okay, now it's looking kind of nice, right? I've got that not P and not Q, which is where I want to have, well, what I want to have, right? So I like that. This Q and not Q, don't like so much. Let's think about that. What do we know about a statement and its negation joined by and? And let's do a quiz. What do we know? Answer would be like a multiple choice thing, okay? And I might just link these all in the same quiz, okay? That might make more sense. So go ahead and tell me, what do we know about a proposition joined by its negation with and? Okay, and I'll give you some multiple choice there, okay? So let's see here. So the answer, which hopefully you did on the quiz and you're not just watching, okay, take a moment. It's for your own good to think a little bit. Hey, come on guys. Alright, so what we're going to use here, we're going to use the fact that if I take a statement and its negation, it's always going to be false. Because and, both of them have to be true with and, but if I have a statement and its negation, they're always going to have opposite truth values, so it's always going to be false. So I know that Q and not Q, that's false. So I still have my not P and not Q, which I really like because I want to see that in my final answer here. Or, and we're still kind of leaving this piece hanging here. We're going to take care of it later. All right. Now, what do we know about a statement joined by or to a false proposition? So my question is, what do we know about P or false? Take a moment. Answer that question on the quiz. It's P. Okay. All right. So we've got a proposition, a compound proposition, joined with or with false. So that means I'll just have that compound proposition left. It's going to take over. Its truth value will determine the truth value because we've got or false, right? So if P is true, the proposition will be true. If it's false, the proposition will be false. So if the false doesn't affect it, it's just going to take over there. All right, so we like the way that first one's looking because it's got this exactly. So we want to try to make this second one look like the left-hand side, okay? And this is going awfully smooth, okay? I promise you, when you do it, it will not go smooth the first time, okay? And believe me, I just learned this, you know, I don't know. Well, I don't know. When I learned it, it took me a while, okay? Lots of torn up pieces of paper and frustration, okay? So this is all magic now. Somehow magically I know step to step what to take, but you're going to have to play around and make some mistakes, okay? And that's okay. Just keep practicing. All right. So now let's use the distributive property here to combine that P with the Q. We want those guys to be by each other. So the property I'm going to use here, I've got two propositions joined by or, and I'm distributing an and R. So I've got P and R combined by or, Q and R. Okay? So I'm going to take and P, distribute it to not P, and P, distribute it to Q, put an or in between. And that first guy's just going to hang out for a little bit. We're not going to worry about him right now. We really like him. He is looking good. Or, and let's distribute. So we've got not P and P, or Q and P. There we go. That is looking very good, right? Because basically we'll be able just to follow these same exact steps that we did in the last one. We'll be able just to do this again, right? A proposition and its negation is false. A proposition or false is the proposition. So let's just apply those steps again. Let's write them down though, just the way we know and your reader knows, your reader me, knows what logical equivalences you're applying. Because you might think it makes perfect sense, right? But you might as well communicate it with me so that it makes perfect sense to me too. So let me in on your head and oops, it's paradox. Oh my gosh. Oops. Hey, where'd you go? What did you do that for? Oops. Alrighty. So we're going to apply those properties. Apply those logical equivalences. The first one we're going to leave. The second one, we're going to write not P and P is false. Now, if I take false and join it with a proposition, I'm going to just get the other proposition. Q and P. Alright, this is looking pretty good here. Pretty good, right? Here's this that we're looking for. We're also looking for P and Q. So the order's a little bit off, but we are really, really close. So let's fix the order. First, one thing at a time, okay? Don't be doing crazy, crazy things and getting me all confused. Q and P, P or Q, P and Q, logically equivalent to Q and P. So they're commutative. That's all that that's saying. They can be done in any order. Just like multiplication, 5 times 3 is 3 times 5, right? So let's go ahead and apply that logical equivalence to the P, Q and P, so that that's in the order as that final compound proposition we're trying to work towards. And really, I mean, we should do these in 2 separate steps because, I mean, or lists commutativity of and operator and the commutativity of the or operator. But so now we've got the innards of those 2 pieces in the right order, but these guys are swapped from the order of what we're trying to go towards here. Okay, I'm trying to go towards this guy. So I know that or is commutative, is a commutative operation. So I'm going to use the fact that P or Q is logically equivalent to Q or P. Okay? And list them over and over again. Tell me every single step what you're doing. Okay? You might see we've written the same thing over and over again, and it's annoying, but I know exactly why you did each step. Okay? So let's go ahead and we'll have our final result here that we're trying to get to. So we used a series of logical equivalents and we replaced it, and we got to our final answer. We got to our final compound proposition that we are looking for, okay? And notice the way that I stated this, using a series of logical equivalences, okay? On your exam, don't ignore this and give me a truth table. I will be upset. Well, I will be bummed out, you know, because that won't earn you much credit. You're not following the directions, right? Follow the directions. Use a series of logical equivalences as shown in class, okay? All right, guys, so do some practice. I think maybe I'll do like a little mini quiz here so that hopefully you can practice this a little bit more before you jump into the homework. So that will help you learn here. So I will talk to you soon. And next you'll be learning about quantifiers and predicates, I think. So, alrighty. Thanks, guys. Let me know if you have questions.